Okay, so jumping right back into another example from chapter 8. Here, this one revolves around Whole Foods, the all natural grocery chain. Won't bore you with reading the problem, you can do that yourself. Essentially, this is a comparison between the Whole Food stores versus other stores. The problem talks about how the stores are bigger, but also that they make more money per square foot. So the average supermarket makes just under $400. But then we are presented with some evidence that Whole Foods makes more dollars per square foot. So they have taken a random sample. This is a key point here, a random sample of 10 Whole Food stores. And these are the values that are found from that sample per square foot. So using the facts that the sample mean and the sample standard deviation are as follows. Answer parts A and B. So this problem is simplified a little bit because the averages and the average and the standard deviation are given to you right away. Sometimes on the exams you will be asked to do that, and it just complicates your life a little bit. So taking down some notes, we know that n is equal to 10. We know that the sample average is $846.20, and we know the standard deviation of the sample, so it's S, is equal to $32.86. Part A is asked of us to calculate the 95% confidence interval given the sample, and we are told some very important piece of information here. It says assume normality. So why is that important? Because of the following. It's important because of the following. So we have a small sample size. We do not know the real population standard deviation. And so we need to make a choice, Z or T. The only way you can use T is because we are told that the distribution is normal. If we were not told this, we can't use Z or T. So it's not just automatic that just because n is small and we know the sample size, sample standard deviation, that we automatically use T. There has to be another assumption that has to be made, which is that the distribution of the values in this particular case is normal. This is such a small sample that we can't just approximate or just make the assumption. So we have to be told. So in this case, you're told that the distribution is normal, and therefore you use T in your problem. So just to get that out of the way. So this is your equation. And so we need our standard normal number. So we flip over to the T table. I'll work on here for a second. So I know that alpha is equal to 5%, which means that alpha divided by 2 is equal to 2.5%. That is everything here in this tail. And therefore, I choose this column. This is a symmetrical distribution, so on the other side there has to be another 2.5%. But I don't care, I'm just looking at one side for the moment. Because they're symmetrical, any value I find on the right-hand side will be the same for the left-hand side. So I choose this column, which corresponds to the 2.5% I want in my tail. The other piece of information I need is my degrees of freedom, which is equal to n minus 1. In this case, it's equal to 9. The ninth row, 2.5% column, I have a standard T value of 2.262. So that's my setup. And I calculated the margin of error, essentially all of this guy, to be 23.5. Just rounded to 2 decimal places at this point. And so when you calculate your interval, I have an upper limit equal to 869.71 and a lower limit of 822.69. And obviously this is the middle. Part B says, are we 95% confident that this population mean is greater than $800? Is it? Well, 800 is somewhere here on this side. And because it clearly falls outside the range, then we have a pretty good indicator and pretty good evidence to say that the real population average is somewhere within this range. We have a 95% confidence in that statement. And since it's larger than 800, then yes, we are 95% confident that this population mean is greater than $800.